Okay, it is 3 o'clock. Welcome everyone to day 2 of the Virtual Climate Action and Agricultural Symposium. Let me go to the next slide here. So for today's participation, type your questions into the chat. It's super helpful if you put the speaker's first name before you put the question. That way we know who it belongs to. We have designated Q&A time after each kind of session or group of speakers, and we'll prompt them then. You can also use the chat for comments. You can use the reactions feature, which is at the bottom of your Zoom bar. And if you need any assistance, technical assistance with the Zoom aspects, you can message PSU support. For continuing education units today, we have Certified Crop Advisor again. We have 1 hour of soil and water management. At the end of the day, a QR code will be displayed at the end of the presentation, so you can scan with your CCA app. You just open the app and take a picture. If you don't have the app, no worries, just send me an email to anrprogram@ucanr.edu and I can get you automatically logged in for credit. Just make sure you stay in for the whole meeting to get the credit. We also have San Diego Region Irrigated Lands Group credits today. Please remain logged in and engaged in the meeting for the duration of the event, and we'll take the list of logged in participants and submit the hours on your behalf. If you have any questions, again, just email the ANR program support. And I think that's all I had, so I will turn it over to Jan.
Thank you, Kelly. Appreciate you getting us started off with those logistics. If you were not able to join us yesterday, this is your first day on our week-long series of webinars. I want to say welcome and thank you for joining us today. Again, my name is Jan Gonzalez. I'm a program coordinator, community education specialist with the University of California Cooperative Extension, the San Diego office. And I'm part of this program that's climate resilient agriculture. It's designed to be, or the objective is to reach growers and a broad range of stakeholders in providing resources, information assistance in helping our unique agriculture industry thrive and be resilient and sustainable in these times of climate and extreme climate change trends, extreme weather events, and other climate-related challenges. So again, thank you for being here with us today. I'll introduce the speakers, but won't read their full biographies. You can find those online as part of our event web pages. And I did want to let those of you who were a part of yesterday know that I was able to get, I think, all of the resources that I had shared during the wildfire preparedness and agriculture kind of talk up on the website as well yesterday. And just learned this morning, I thought it was kind of timely. One of the points we made was the need to be careful with tools and machinery, use of equipment on the farm when during intense weather days or red flag days. And, the fire out at Ramona yesterday was started with a spark from a piece of grinding equipment. So if you have a chance, go and check out those resources again. So without further ado, let's get started. We've got a day full of irrigation and energy focus with Generac and different microsystems. So Gerry Spinelli will get us kicked off today with our first talk on irrigation management in the field. Ready, Gerry?
Ready, Freddie.
Share your screen. Okay, go.
Yeah, thank you, Jan. My name is Gerry Spinelli. I hope you can see my screen. I hope you can see my screen.
Yes, it looks great.
Thank you. And I am the production horticulture advisor for nurseries and floriculture here for San Diego. And my background, among other things, is in water. And when I was young, I really didn't know what to do with my life. So my mom was there cooking stracotto, and she said, Gerardo, you should get into water because it's the most important thing, and the future will be about water. And so whether so then I did, and so 10 years later, global warming and climate change started becoming important. So I don't know if mom was right, but with more extreme weather and less rains or less water or more concentrated rains, etc., the only one of the things that scientists seem to agree on is that we'll have less water, whether because we'll have less rain or because we'll have more evapotranspiration, etc. So and so we have to manage this water, this irrigation in the field more efficiently. And so here I put some pictures. This is my friend Alejandro measuring pressure. This is my friend Claudia measuring pressure, and he measures 93 psi and she measures 5, and we'll get back to it later. But what I'm trying to communicate here with these slides is that there is a strong people factor in managing irrigation in the field. It's not only science, it's not only technology. You have to train and you have to work with the people that go in the field, and they actually every day with the boots on the ground. The first thing I'm going to talk about today is I'm going to define what acre feet, acre inches, feet, inches, gallons, volume, area. Everybody seems to be confused about this, and those that aren't, please forgive me. I'm going to bore you for only 3 minutes. Then I'm going to talk about pressure a lot, because in my opinion is one of the greatest causes of bad distribution uniformity. I originally meant this presentation to be a kind of a high-level overview of a lot of things. Yeah, you can measure pressure, you can train your irrigator, you can use soil moisture sensors. But then I was told that 80% of the audience are either growers or consultants, and so I decided to put a little bit more meat to make it a little more spicy. And so I'm talking about pressure mostly. I'm going to briefly mention how to measure distribution uniformity and other things that you can do in the field to improve your management, including training irrigators and moisture sensors. So why, when we talk about rain and when we talk about evapotranspiration, we use inches, like depth. This was the thing that used to confuse me as a kid, because then I would hear in the news the weather person saying, "Oh, we're going to get 1 inch of rain," and I was thinking, well, how can you get 1 inch of rain? How can you measure rain in depth? So here I drew this big pool. Imagine a pool that has one area of 1 acre, and there is 1 inch of water in it. That volume of water will be 27,000 gallons. And we call that volume of an acre inch. And we write it this way. We don't write acre/inch, because it's not divided, it's multiplied, right? Like when we're in school and we had, and the teacher said to calculate the volume of this solid, you have to multiply the area by the height. So it's the same. We're multiplying this area of 1 acre by 1 inch of depth, and we get this volume of water that corresponds to 27,000 gallons. And those that are visual, those of you that like to think visually like I do, may benefit from thinking about these 14 water trucks. Each of them holds 2,000 gallons. So 1 acre inch, when I think about 1 acre inch, I think about these 14 trucks. And when I think about 1 acre foot, I think about 2,000 gallons. So 1 acre inch, when I think about 1 acre inch, I think about these 14 trucks. And when I think about 1 acre inch, I think about these 14 trucks. And when I think about 1 acre foot, I think about 1,000 12 groups of those 14 trucks. And so that's the way that I remember that we're talking about the volume. So this is what an acre range corresponds to. And as a curiosity, in generally, as a rule of thumb, 1 week of evapotranspiration on 1 acre will use this quantity of water. So about 1 inch per week. So yesterday I was in my yard, and I have a small yard because I'm poor, and my neighbor has a big yard because he's rich and he has a big pool. And I spend all my money in this high-end Italian coffee. So I was there drinking my coffee mug and looking at my neighbor's pool, and it was there empty. And then I forgot my empty mug in the yard. And then the next day I came back, and it rained overnight. We got 1 inch of rains, and my mug had 1 inch of water, and my neighbor's pool also had 1 inch of water. Of course, in the pool there was a lot more volume than in my mug, but both of them had 1 inch. So that's what they mean when we say we get 1 inch of rains. The volume will be a lot larger, but the depth will be the same. And the same holds for transpiration, for evapotranspiration, for evaporation. So if I leave my mug out there, after more or less 1 week, the mug will be empty and the pool will be empty too. So this game works also with the field, whether you have a small 1 acre field or you have a big 100 acre field. And that's why we can say sentences like the average San Diego yearly rains are 10 inches, or things like crop specific, like almonds require 50 inch of water per year, right? And you can also say 50 acre inch per acre, which is an okay notation, but you could also cancel out these acres, and you would be left with inches. So I hope that everybody is completely either satisfied or confused by these concepts, but please do not hesitate to ask me questions in the chat. And now I want to talk about pressure. So an even distribution of pressure will give you an even distribution of water when you irrigate, just because more pressure, whether you irrigate with a sprinkler or you irrigate with a dripper, more pressure will push out more water. So while I'm here weighing my pots, you can look at these two irrigation blocks out here, and one is maybe 20 feet higher in elevation than the other one. So everything else being equal, the pressure up here will be lower than the pressure in this block down here. And the same principle holds of when you swim in the pool and you go deep and your ears hurt. And that's because more pressure develops when you go deep. And the same principle holds on a pipe. And this principle holds whether water is moving or not. So if you have this pipe is full of water, you have high pressure down here. And if it's full of water that is moving in either direction, doesn't matter, still this principle holds. Are there any questions? Okay, either everybody's asleep or everybody is completely clear. The other factor is friction. When water moves in a pipe, it loses pressure because of friction, and this has to do with the conservation of energy, and because pressure times volume means energy. So if you have a gallon that is here at the beginning of the pipe, and you hold that volume constant, and you move that gallon down towards the end of the pipe, it must have lost energy because it moved, but the volume stayed the same, so the pressure must have reduced. So every time that water moves, the pressure decreases. And the ramification of this is that if you have a drip line and you're irrigating your plants, at the beginning of your drip line, there will be higher pressure than at the end of the drip line. And so the first plant would receive more water than the last plant. And more pressure losses because of friction will happen when you have a longer pipe, of course. When you have the diameter of the pipe that is smaller, so everything being equal, it's better to have a larger pipe. Of course, it's more expensive, so there's a trade-off there. If you have a larger flow rate that you are forcing through that pipe, you also lose more pressure. And also there's a factor that has to do with the roughness of the surface of the pipe. So these two principles, friction causes a pressure loss and elevation causes a pressure loss, are additive. So if I'm pumping a pipe uphill, I'm losing pressure because of two reasons. One, because I'm going uphill, and one, because of friction. So you should never irrigate uphill. You should first pump the water uphill and then irrigate downhill. Otherwise, these two effects will sum. The two effects are additive. Any questions about this? So do not do this. Do not do this. Okay, so this is a job that I did a long time ago, and we're measuring this irrigation system. This is the pump, this is the pipeline, and these purple numbers are the pressure in PSI that we measured. So here at the pump we measured 50, then we walked to the main line, here we measured 40, then at the filter we measured 20, and then here there are, each of these was an irrigation block. We just measured 3 of them. But here, this block right after the filter was saying 18 PSI, and this one 15, and this one 12, and the plants at the very end of this block were saying 6 PSI. So now you have this big difference in pressure, right? Some parts of the fields are irrigating at 6 PSI, and some parts of the fields are irrigating at 18 PSI. And this is what you're trying to avoid. You're trying to have the pressure in your field as even as possible, because with more pressure, your emitter will produce more water, and you will have a very bad uniformity of distribution of how much water is applied to your plants. So keep this in mind, and we'll go back to this later. Now, to wake you all up, I have a quiz, and here I have $1 generously made available by Dr. Gerry Spinelli, and whoever gets all the answers ready will win this $1. This may look silly for some of you, but I want you to guess how much pressure you need for a drip system, how much pressure you need for a micro sprinkler, and how much pressure you need for this big rainbird, so-called rainbird impact sprinklers that are used a lot in vegetables. So you have just 4 answers here, and I'm going to leave you just another second. Everybody can pick a number, but you can just guess by yourself that probably the dripper that just needs enough pressure to get out of that dripper doesn't need as much pressure as a big impact sprinklers that needs to spray that water, needs this squirt of water that needs to get 30 feet away to the other sprinklers. So you can just by intuition, you can guess that the dripper will need low pressure, and in fact these are sometimes called low pressure systems, and the sprinkler would need more. So I see that our coming answers are coming. It's incredible what you can get people to do for only $1. Okay, and the winner is, the answer are about 10 PSI for a drip system, about 20 to 30, there's some variability in micro sprinklers, and about 50 to 60 in these impact sprinklers that are those that need the most pressure, right? So now I want to go back to Alejandro and to Claudia. They're trying to do a good job, they're working really hard to manage their irrigation very well, but just because they don't have a pressure gauge, just because they cannot measure it, they don't know. They think they're doing a good job, but Alejandro is way higher than any irrigation system requires, and Claudia is way lower. So there's this quote from Lord Kelvin that says, "To measure is to know." And this is a good example, right? If you don't have a pressure gauge and you don't measure it, you just don't know. Okay, now I want to talk about pumps. Pumps have a behavior that also has to do with the conservation of energy. And if you have deeper questions about this, you're talking to the wrong Dr. Spinelli. You should ask my father, that is a physicist. And the reason why I ended up in horticulture and agronomy is because I don't understand math and physics very well. But pumps behave on curves, and this is what a typical pump curve looks like. And what this curve is telling you is, if you ask more flow rate from me, I will give you a lower pressure. And this is conceptually, you can conceptualize this if you think about pressure. If you think about pressures in terms of how many floors in a building you can go up, and flow rates, you can think of how many buckets full of water, these Home Depot orange buckets full of water, you can take in 10 minutes. And if you think about this, how many floors you would go up in 10 minutes, you will probably come up with a situation where if you're taking more water in time, you will have to go up less floors. And this is the same for a pump. And so the ramification that this has in terms of irrigation management is that if you open more blocks, the pressure will reduce, the pressure will drop. Yes, Kim. Yes, Kim, thank you for asking. The definition of flow rate. Flow rate means a volume in time, and the units are gallons per minute, like it says here, or liters per second is another good unit. What's the volume? It's a volume of water. It's a volume of water in time. So as I said, think about two buckets full of water in 10 minutes. 2 buckets full of water in 10 minutes. How many floors you can take them up? Or in terms of an irrigation system, you can say, okay, my irrigation system has 100 sprinkler heads per acre, and each of them takes 3 gallons per minute. Therefore, when I open my irrigation block, I have 300 gallons per minute. All this water, all this flow of water that is going into my irrigation system through my main line. I hope I answer your question. We have a session for questions later, so please keep them in mind, and I can talk about it more. But the ramification of this principle for irrigation management is that you should size your irrigation blocks according to the pressure that you want to achieve. So in this situation, say that you know that when you irrigate this block, you have, that is 0.9 acres, you have enough pressure, then you will probably have to irrigate this 0.6 with this 0.3 together, and this 0.5 with this 0.4, right? To put them together and achieve the same area, and so it will be the same flow rate if your irrigation system is all the same, right? But then this 0.74, what can you do? You will have to irrigate it by itself, And because of this principle, you will have pressure that is too high. And so you will have to install a pressure regulator there that is a device that drops the pressure. And the same for this block that is 0.63. The point is that you cannot have the flexibility to irrigate today this block by itself, tomorrow these two blocks together. That's something that doesn't happen with normal pumps. Now, these days, there is devices called VFDs, variable frequency drives, that give you the flexibility of changing this curve. So what I just said is not true anymore, or is not always true. But the VFD costs tens of thousands of dollars. So if you do not have it, and most growers don't have it, you have to make sure that you size your irrigation blocks according to your pressure. You cannot have the flexibility of opening today 1, today 2, and tomorrow 2, and the day after tomorrow 3 blocks. You can measure distribution uniformity with a catch can, and you can do something simple with bottles, with buckets, with Tupperware. You can hire a guy like myself that goes there with a clipboard and calculates all the numbers and then runs statistics on it. But I encourage you, if you're a grower, there is a lot that you can learn just by driving to the dollar store, spending $20 in Tupperwares and putting them out there, and just by looking at them, you will learn a lot. What else can you do? Make sure that your irrigator has a gauge and knows how to measure pressure, and knows these two simple things, these two numbers. There is a lot that you can improve just by measuring pressure and being able to adjust it. You can buy pressure regulators, and you also will have to adjust it, and that's what my friend Miguel and I are doing here. We are adjusting the pilot valve of the pressure regulators. Or you can buy these other pressure regulators. It says 25 here. I hope you can read it. These are fixed at the pressure that you buy. You buy them for 25 psi downstream. Doesn't matter what's upstream. They will always put 25 psi downstream, and these are pretty common. Make sure that your irrigator fixes leaks. Make sure that your irrigator knows how to install these Schrader valves, and talk to a person like myself if you don't know how to. These are just the same, these are just like those that you have in the tire of your car, and make sure that they have a pressure gauge so they can go there and measure the pressure in your irrigation system. Pressure regulators come in different forms. These are those that you buy them for a specific pressure, 10, 15, 20, or 25 psi. These are cheaper. You just buy them and you leave them there, and they do their job by themselves. They have a spring inside that the more pressure there is, the more chokes and the more pressure loss it causes. These other ones are more expensive, are up to $1,000. But here you have a pilot. This thing is called a pilot valve, and you can there go manually, and you can adjust, and you can get the downstream pressure that you want. So what would that map, what would that field that we looked at before look like if we installed pressure regulator? These orange triangles here are pressure regulators. Now, downstream, we always get 12 psi. So now you can see that the pressures are a lot more even throughout the field, and the distribution uniformity is a lot more even just by installing these 3 devices at each block. You can also train irrigators, make sure that they know what pressure does to a drip tape or to a drip hose. Do they understand the difference between different drip tapes that give different flow rates? You can also train them on some theoretical concept of irrigation management. In drip systems, make sure that you flush regularly, and make sure that your flush valves are accessible. If they're buried like this one that we're digging out, probably it will not work very well. If the ends are plugged, probably it will not work very well. Yes, Jan, I know that.
About a minute there in a minute.
Now there is pressure regulators that you can put directly at the sprinkler head, and they cost about $2 each. I'm a great fan of tensiometers if you want to measure soil moisture, because they're very simple machines. They're not even a machine. They're just a pipe with a gauge that you can look at. And the more dry the soils get, the more dry the gauge tells you that it is. And you can irrigate accordingly. In summary, I summarized what I just said. Here's a link of a person that knows a lot more than myself, Dr. Franklin Gotti at Cal Poly, that talks about distribution uniformity for 1 entire hour. And this is my contact information. Please contact me if you have any question, and take a minute to take this survey. And back to you, Jen. Thank you very much.
Thank you, Gerry. That was great. I know I learned a lot from that. If you'd like, you can go ahead and put the survey link in the chat box for folks. If I don't know if that'll be helpful or not. But thank you again. Just a reminder, I can't recall if Kelly mentioned this at the beginning, but we are recording all of our sessions this week, and they will be available hopefully within 2 to 3 weeks after this week. And we'll let everybody know how to access all the resources and information and videos and such, okay? So next I'd like to introduce Ali Montezar. He is an irrigation water management advisor for San Diego County and Imperial counties, and he's based in Imperial County. He's gonna talk with us today about irrigation management tools and technologies. So Ali,
thank you, Gerry.
Screen.
Yeah, can you see the screen? Yeah, thank you, Janice. Good afternoon, everyone. As Janice mentioned, my name is Ali Montezar. I am irrigation water management advisor in Imperial, Riverside, and recently UC added a new assignment, San Diego County, as a new assignment for me, and it's a pleasure for me. So I hope everyone is doing well and healthy. In this talk, specifically, I'm going to share with you some tools and technologies that are available to more precisely we do irrigation management. So specifically, I will talk about tools and technology. Well, I think the importance of efficient irrigation in San Diego County is a common sense. To me, it really is a common sense, because we have one of the most expensive ag water in the state. There is competition for water between different sectors, and we are expecting more impact even from drought and climate change in the future. But it's not everything. I think besides that, with efficient irrigation, we can improve production and quality. There are a lot of plant disease are irrigation related issues. So we can reduce all those. We can conserve resources, specifically water and fertilizer, and as a result, improve water quality, which I think in San Diego County is very important for all of us. When it comes to irrigation scheduling, and we want to do more efficiently irrigation scheduling, we need some knowledge and information, which without that knowledge, we probably cannot do a good job with irrigation management. We need some basic information on soil water holding capacity and crop sensitivity to water stress at different growth phases. They are very important, but they are basic information. We also need to, I think Gerry mentioned, to make sure we track the amount of water we apply over time and how much was the effective rainfall for us in the region. But there are also two very important parameters we need knowledge of it. These two are very complicated. One is soil water status, the other is crop water use or evapotranspiration or ET. So the reason these two parameters are very complicated is because they are very variable over time and season. That's why we need tools and technology to track their values carefully for irrigation management. So in this graph, you see soil water content at multiple depths in a date palm under drip irrigation. We see a lot of fluctuations here at different depths at the different time. So these fluctuations reflect irrigation events. This is another graph shows crop water use by date trees in 12 months. You obviously see how variable is crop water use over the season. So it changes from a maximum of 0.35 inches a day to nearly zero at late December. So let's consider soil as a water storage. What we do in irrigation, we basically refill this water storage. When we refill it with irrigation, 40 to 5% of this water available in the soil can be uptaken by crop without any stress. So this available water is different in sandy soil, in silty clay, in clay loam. So each soil has different capacity to hold water. Just give you an example here. You see here sandy loam and silty clay loam. If we have these two soil and we have a plant with 3 feet effective crop root zone, this is the amount of water we have available for crop. So in sandy loam, we have about 2 inches if the soil is full. In clay loam, we have about 2.93 inches. So basically, it shows that clay loam could have 45% more water available for a plant to use. And this is why we are more comfortable to manage heavier soil than sandy soil. And also, this is the reason that we should schedule more frequent and lighter irrigation events in sandy soil and less frequent and heavier irrigation events in silty or clay loam soil. This is the main difference we need to consider for irrigation scheduling. So when it comes to irrigation scheduling, we recommend ET-based irrigation, which is very effective approach for irrigation management. So what we do in this approach, we basically follow crop ET and monitor soil moisture over the season. So if we want to calculate ET, crop ET, there is a simple equation. This is the equation you see here. So it's crop ET is equal KC multiply ETO. So ETO is reference ET. It's the ET for a well-managed non-stressed grass. It comes from Siemens station. KC is a little bit complicated factor here is crop coefficient. It depends on many factors. So KC value is individual for each crop. It depends to light absorption, irrigation system, the age of trees or growth period, soil type, and irrigation practice. So all those drivers affect crop coefficient values. And this is very important to always go with more proper and accurate crop coefficient for irrigation scheduling. So as I mentioned, ETO can be obtained from Siemens station. We choose the closest Siemens station to our field or orchard. But there are also another tool, very user-friendly tool, is called spatial Siemens. So if your field or orchard is far away from Siemens station, this is important, or you are in a hilly area, it's recommended to use a spatial Siemens rather than Siemens data. So what spatial Siemens does is it integrates Siemens data from different stations. As you might know, we have over 150 Siemens stations in the state of California. So spatial Siemens integrates all those information from the station, integrate with remote sensing, and also topography maps is very important, specifically for, as I mentioned, with the topography we have in San Diego. And then develop daily ETO for the entire state of California. So it developed a map with 2-kilometer resolution. So your field is a part of this map, and you can retrieve the information for your specific location on your field and that's the ETO for your field. This is very important. It doesn't show ETO in the ET station. That's your field. So it's very user-friendly tool. All you need to do is you go to CIMIS website, you seek for a special CIMIS. On the top of this page, you can see it, and you create a free account for yourself. You just provide an email address. And then you go, you just add the coordinates of your field, as many as you feel you have, it doesn't matter. Every day at 6 a.m., Department of Water Resources send an email to you with the information of ETO for your fields, the fields you provided the coordinates for 7 days. So which means you don't need even to go to CIMIS website anymore or download or track anything in CIMIS website. So the data every morning is mailed to you. So as I mentioned, to calculate crop water requirements, we also need KC values, and this value is very important. So if we have more appropriate or accurate KC values, we can calculate or estimate more accurate crop ET. In these tables, you see crop coefficient for avocado, monthly crop coefficient. This is for, developed, I believe, 30 years ago for avocado in San Diego. Still, we have this, I cannot verify they are really accurate in this time with the cropping pattern and system we have for avocado, but we try to update this information. So the other table shows KC values every 2 weeks for a grape. There are also some recommendation, very general recommendation for avocado and citrus. For example, it's based on the how tall are the trees. For example, if the trees are less than 3 meters tall or 10 feet tall, you can consider a KC value of 0.7 for the entire season. But there are some other consideration, and it makes very complicated the story of KC values. So this is the result of a study we did in El Dorado County a couple of years ago with Dr. Richard Snyder from UC Davis. We tried to evaluate a crop coefficient and crop water use in different slopes. This is important for San Diego County because we have a lot of hilly area, and when we have hilly area, the KC value is changing dramatically sometimes. So we measure actual crop ET in north facing with 8% slope and south facing with 14.4% slope. The results are very interesting. So we observe about 22% higher ET in the south facing slope. In other words, in the south facing slope, each vine used about 340 gallons per season per 5 months period. In the north south facing, each vine used 270 gallons per period. This is very significant. You see, 22% is a huge number. You know, if a grower has orchard in south facing, it means so he or she needs to go with different irrigation scheduling or different hours of irrigation in each irrigation event. I think they are very important to consider for irrigation scheduling if we want to do a better management. The reason most likely is the solar radiation. So as you probably know, south facing takes more solar radiation, and solar radiation is the main energy for evapotranspiration. So that's why on the south facing, we have more evapotranspiration. This is another example. So for large canopy, citrus with large canopy versus citrus with high density. So you obviously see different crop coefficient. For large canopy, we have about a KC of 1. For high density in San Joaquin Valley, 0.7. Still is significant. Even you calculate ET, a crop ET for the entire season, this is significant differences for these 2 different canopy types. So this is important information we need to consider. So one challenge we are facing about KC is the KC we have on the website, UC website, so we have for each crop. But one of the issues we have is, so we developed this information years ago. So with different irrigation practice, we had different cropping systems, we had different technology when we developed this information. So when we use today this information, probably, so we need to, to update this information and make, with the new cropping system, if we use drip irrigation, so the irrigation system is different. If we go with high density cropping system, so the crop coefficient changes. So I started to, we actually in UC started to update this information for different cropping system. In Imperial and Riverside, I started 4 years ago. I updated for several crops. These are the pictures, some of the pictures of this crop and my station. I'm hoping during the next few years, I start for some major crops in San Diego County as well. So what we do, we use these sensors and equipment to measure actual crop water use and determine actual crop coefficient under different real condition in commercial fields, which is the real practice, and the real data is coming from the real practice. So as I mentioned, I'm hoping to start a project in San Diego and to develop some information of this. So this is very interesting to me. During the last few years, I was reached out several times by several growers from San Diego and Temecula, and they asked me about KC values for wine grape and avocado. This is great. It means our growers are very sensitive and they want to be more efficient and do a better job with irrigation efficiency and irrigation improvement. And we are all here to help our growers on this. There is another tool called Thule. So Thule uses surface runoff method, is a kind of commercial use of the technology I mentioned in my previous slide. So these tools measure only sensible heat flux from the field, then use some satellite data and come up with the daily ET for field. And it's kind of commercial. There is sensor and there is a company provide this sensor. So my evaluation for different crops shows this estimation for farm scale is great and is reliable. So I evaluated the results for several crops in Imperial. In the lower left slide, in the lower left of this slide, you see the result of one evaluation I did for alfalfa. So we observed about 5% differences between the result of my tower and Thule, which I think is not significant and is reliable for or growers to use these sensors. So we can also use drone and satellite to evaluate crop ET and crop water stress. Basically, what we do here is we use these images to retrieve the values of vegetation indexes and canopy temperature. One of the most popular vegetation indexes is NDVI. Probably you heard before about NDVI. It's very popular and important vegetation index. There is relationship between NDVI and KC values, and also between canopy temperature and crop water stress, crop stem water potential. So we try to find that relationship and then use satellite or drone for irrigation management. This is the concept, the main concept of using satellite data or drone. So here I have two maps from my alfalfa field in Palo Verde Valley. So the left side map shows NDVI values. The values changes from 0.2, less than 0.2 to 1. You see the scale. And we see variable NDVI in the field, which means different parts of the field might have different crop coefficient. When it comes to orchard, probably we can do a better job with irrigation management. If you have alfalfa field, probably it's really hard with flood irrigation to go with different or variable rate of irrigation in different parts of the field. But if you have orchard, probably you can do a better job and variable irrigation with the amount of KC values you have. The right side map shows a thermal map or canopy temperature from that field at the same time. So you obviously see some levels of water stress in different parts. Specifically, if you look at in east side, northeast side of the field, you see some water stress. So the concept is, when we have higher canopy temperature, so we might have some water stress on that part of the field. So this is another, the result of another project is very interesting. So in this, the researcher developed a linear equation between KC value and NDVI, and easily we can take some images and we have NDVI, and from this equation we can calculate KC value of the orchard, citrus orchard, and then calculate the ET. But one of the
Ali?
Yeah.
Excuse me. About another minute, okay?
Yeah, sure. I will.
Thank you.
Sure. So I will try to because this is very important. I would like to mention this is a free tool called IRISAT, developed by Australian scientists. It uses Landsat and Sentinel NDVI images to develop KC maps. I have a polygon, a red polygon here. It's an interest area for me, and avocado orchard around Escondido. So this is the NDVI map. So provide by this tool. This is the KC, and based on that, you can develop the KC values over time. So I developed for this orchard for the last 3 years. The result is very interesting. You can see, how crop coefficient changes in this orchard, and if you integrate this information with special sims for this orchard in Escondido area, you can calculate easily the amount of crop water needs in this orchard. So this is one of the benefits. This is the website you see here, the link. So you go there, you create an account for yourself, and you put a polygon from your orchard, and you can just monitor what's going on with crop coefficient and ET over time. So I think I don't have time to continue, but I wanted to just mention soil moisture also are very useful and critical, equipment, because they can answer a lot of questions. Not any other equipment can answer. How much water, how is the water status at early season? This is the question all the growers with 3 crops they have. And if you have soil moisture sensors, you can answer this question. When is the right time for irrigation? Is my soil profile full? When is what is the length of irrigation? Do I need to change anything about my irrigation? They are all the main question we always have for better irrigation management, and these tools can answer this question. So if I don't have time, probably I will stop here. Okay. Would you like to stop me?
Okay, thank you. Yeah, thank you, Ali. Appreciate it. Well, there are a couple of questions. If you have any questions for Ali, do you have much longer to go? Because
2 minutes more about soil moisture. I wanted to mention a few things.
Okay, why don't you go ahead then?
Okay. Okay. Oh, I don't know if you see this information.
Yes, you're back on. We see it.
Oh,
you just need to put it into presentation mode, and then you may have to switch. Let's see. Yep, just swap the displays.
Yeah, okay. So, yes, what I wanted to mention about, besides the soil moisture sensor, I believe the wireless monitoring system is a big advantage today, because, it makes more applicable using soil moisture sensor. You can just monitor soil moisture status of your field in your your office and manage irrigation through your office. But what is important is, where we install these sensors, telemetry, they are great tools, but the accuracy of the data, this is very important. That's why I would like to mention, the accuracy of the data doesn't depend on the telemetry system. It depends on how you install this sensor, where do you install, how do you maintain them, how you interpret and use for irrigation management. They are very important. Even doesn't matter which sensor you use, because all the soil moisture sensor on the market, they can answer all those questions I mentioned. So this is very important, where we install them. This is very important also. So the location we install them, it should represent the soil texture of the field. If we have tree crops, we need to know where to install. For example, the probe can be about 15 to 18 inches away from the tree trunk, and also about 4 to 6 inches away from the dripper. They are very important. Otherwise, you have the data, but the data might even mislead you. Sometimes you don't have the data. It's better than the data is wrong or mislead you. This is important, caveat here. So this is the summary of my talk. If I'm a grower in San Diego County, so I may benefit significantly from precise irrigation decisions. So I'll go with ET-based irrigation scheduling, but I need also tools. A special SIMIS is a great tool available, developed by Department of Water Resources. It's a free tool, and it provides you a lot of good information about ETO from your field. I need also crop coefficient. As I mentioned, IRIS-SAT from satellite gives you crop coefficient for your orchard. It's still a free tool online. You can go and develop crop coefficient for your field. So you have a special SIMIS, IRIS-SAT, and you can calculate, estimate how much water crop needs, and if you have soil moisture sensor and other addition for better irrigation management. So that's all I have. I hope, and also, the other thing is good to say, of course, ET sensors and telemetry devices are very expensive, but the good thing is there are incentives for it. CDFA and NRCS, they have a different program, and you can go for incentives for those sensors and the support. Actually, if you need them, NRCS and CDFA support to provide you incentives for those sensors. So thank you.
Great, thank you, Ali. Appreciate all this great information and references. We have a couple of questions. Let me see here. Okay, we answered the definition of the flow rate. So for Gerry, how often should you flush the valves in an irrigation system, I guess?
Yes, I think that was referring to drip tapes. We used to flush them every 2 weeks to 1 month. But I think the big variable is whether you're injecting fertilizers and what kind of fertilizers into the irrigation system. Particularly, the organic fertilizers are those that tend to plug the emitters more. So if you're using those, I would recommend to flush often, like every 2 weeks.
Okay. And then a question I had for Ali. SIMIS, does it also take into consideration the wind and humidity measurements? Do they incorporate that?
Oh, yes. The good thing is, yes, when we have a special SIMIS, ETO, already all the weather information incorporate with that ETO, which means if the temperature goes up, humidity goes up, down, the pressure, air pressure, everything. So it's included. It's included in ETO from SIMIS or special SIMIS data. Yes.
Okay, great. Thanks. And then back to Gerry. Does each valve have to be flushed individually?
Yes, that's a very good point. You need to flush each drip line individually. Don't just open them all. Open the end of them. Otherwise, the pressure will drop. And when you flush, you want to have a good pressure, so you will be able to push out all the debris and all the sediment that plugs your emitters. So flush one line at the time. And the way we used to do it is one walk, two people walk at the end of the fields, and one open all the valves, and the other one walks behind them and closes them all. So there's always two drip lines that are open at the same time.
Okay, I don't see any other questions right now. Thank you very much. Do our next speakers ready, Kelly?
They are both here.
Great. Well, I want to thank Allie and Gerry very much for all that great information and the resources. If you had links, if you want to make sure they get put into the chat box, that'd be helpful, I think, for our participants. And I'll make sure I link them on our website as well. So next, I'd like to introduce our next speakers. And I'm really excited to have them join us. They're going to be talking about clean energy resiliency and microgrids. This is Doug Hipple and Tony Mente, and they're with Generac, and I hope I'm pronouncing that right. And they're going to share some information with us about different systems and ways to step towards maybe decarbonization. So welcome. Thank you for being here, Tony and Doug.
Awesome. Thank you so much for having us. Just want to make sure everyone can see the title slide here.
Yes.
Perfect. And then we have 30 minutes, correct, Jen?
Yes, with including some Q&A if you have time for that.
Okay, perfect.
Okay.
So great. So Generac Power Systems, kind of agenda for the topics today. We'll provide a quick kind of overview on who Generac is, our product offerings. We'll talk about the benefits of clean burning natural gas, and then also we'll talk through some microgrid case studies and how we're seeing microgrids used in addition to natural gas to lower carbon footprint compared to traditional diesel solutions. And then we'll also have some time towards the end to field any questions that the group has. So Generac Power Systems, we're a publicly traded entity. We were founded in 1960. We're headquartered in Waukesha, Wisconsin, and we have a little under 7,000 employees worldwide. The bulk of our business and what we're really well known for are kind of smaller residential generators that go outside of homes or small businesses. And then we also have a very large commercial generator offering, which is what we'll kind of talk through today. And that's where a lot of the natural gas solutions that go into the ag and water pump community fall into, as well as the microgrid community. So for product offerings, just to kind of give you a flavor for who Generac is, as I mentioned, kind of down here in the third bar for product types, we're really well known for our small residential generators, but we offer a really wide gamut of product offerings. We have chore products, log splitters, stump grinders, things of that nature. We have mobile generators and light towers. We also recently, 2 years ago, got into clean energy with residential energy storage systems and batteries to complement solar and make solar a bit more effective. And then the product that we're here to talk about today are larger industrial product offerings. All of our products can be offered through a variety of different, energy technologies, whether that's traditional petrol, gasoline, diesel fuel, biofuel, which leverages both diesel and natural gas, propane, or lithium ion in the case of the batteries. From a North American product offering, we have, again, a variety of different mobile trailered options as well. We see within the ag community a lot of interest in mobile generators and mobile pumps that can be moved from site to site, especially on the generator side. in Southern California, we've worked on several projects where folks have had a need or a requirement for a generator that could be moved to various pump stations, especially during PSPS events, to make sure they were able to pump water to their crops. On the stationary units, so units that don't have a trailer and can't be easily transported, we have a wide range of product offering. Everything that we manufacture and build is manufactured in Wisconsin. We are very vertically integrated, so we design the engine, the transfer switch, all of the key components basically on the generator are designed by us in Wisconsin and also manufactured in Wisconsin. A big benefit to our generators is that they can be used for emergency standby use when power is out, whether that be due to a windstorm or a natural weather event, or whether that's due to SDG&E or SoCal Edison shutting off the power because it's dry and winds are above a certain mile per hour rating, and they deem it's a PSPS event. So our units can fire up within 10 seconds notice and take the full load or the full requirement from an electrical capacity standpoint. And then, they can run as long as you need, multiple days on end. I know in some more remote or rural areas, especially during PSPS events, we've seen folks, out of power for as long as 2 weeks, and the generator, as long as it has enough fuel and is connected to a fuel source, whether that be a propane tank or directly, piped natural gas, that generator will run as long as it has fuel for. The other thing to note on this slide, from a size range perspective, we have a very broad range of sizes, ranging from very small generators that would be able to power, again, like a small, couple horsepower water pump on the 25 kW range, or other electrical loads, all the way up to 1 megawatt, which is much larger for cold storage facilities and other more intensive power requirements, greenhouses, a lot of cultivators or other farmers that have heavy water needs or heavy lighting needs utilize that larger genset offering. And we can parallel, so we can combine and kind of daisy chain multiple generators together to enable a more flexible system to make sure different generators are loaded at different times. If you have a lot of variability, in your power needs, if you have, a wide fluctuation in your power requirements, for part of the year during growing or harvest season, maybe you use, let's say you regularly are using, 500 kW, but during a different time in the year, you're only using, maybe 100 kW. We can kind of parallel two smaller generators together to more appropriately balance that fluctuation in load. And then Tony is going to talk about the benefits of natural gas generators over traditional diesel generators.
Yeah, thanks, Doug. So usually when people think of generators or standby generation, they think, I got to get a diesel generator, right? And sometimes diesel is the only solution available, or it's the most convenient solution available. But especially with pushes towards, cleaner carbon footprints and less impact on the environment, we see natural gas as a very logical stepping stone for a fuel between, the traditional diesel fuel generator and then the future of, 100% renewable power. So, some of the questions or some of the benefits of why should I use natural gas over diesel? And natural gas can also be propane as well, just a gaseous fuel as opposed to a liquid diesel fuel. So one of the big benefits is, the fuel will ultimately last forever. There's no storage limit on how long it can sit in a tank, right? So when you have diesel sit for a very long time, it eventually starts to separate. And then you can kind of see that picture in the middle of the screen of a diesel fuel that's completely separated as it sat over time. Biomass starts to form. And so you have to do fuel maintenance annually, usually, on a diesel tank. And the introduction of low sulfur diesel and biodiesels and things actually make that process worse, right? So you have to polish those fuels more frequently, and that, obviously is added cost and complexity, as well as the fuel in very cold environments can gel up and freeze. You have heaters, and there's just a lot of complexity with that fuel where, if you have the access to a natural gas pipeline, that obviously is, ideal, right? You can connect directly into a gas pipeline to the genset and have essentially an unlimited fuel supply, right? So you don't have to worry about getting trucks there to refuel. There's no real fail point in that that gas infrastructure. So the genset can really run for as long as you need it. If you don't have access to a natural gas pipeline, that's where we see propane as a very viable solution as well. In that case, you do run into the same struggles of you have to get it trucked in, but again, there's no limitation on how long that fuel can sit inside of that propane tank. Another big concern is, as we're starting to maybe try to use that backup generator out of a utility outage. When you have a diesel engine, you're required to be Tier 4 final. Can everybody hear me still?
Yeah, you went
Yeah,
out for
you
a
cut out
second.
shortly.
Yeah,
you're
sorry
okay.
about that. I just got a little thing that popped up that said my internet is unstable, but then it went away. So apologize for that. I was just saying, if you want to use that diesel engine outside of emergency standby, right? So outside of a utility outage, you now need to have a Tier 4 final product. So from the EPA, that's the requirements to have a very complex after treatment on top of your diesel to make sure it's extra clean out of the emission cleanup system. So you can kind of see in the lower right here, just a very, very simplified version of what is included within a Tier 4 final after treatment on a diesel, right? So you have a first section that basically takes the carbon monoxide and the hydrocarbon emissions, as well as the particulate matter, and kind of eliminates those. But then you still have a concern for NOx emissions, right? And those are things that can cause acid rain and some bad things like that. So then there's a whole nother system that's needed on these called an SCR. And that's where you may have seen like diesel emission fluid and what used to be urea. That system is very complex and very expensive. And there's multiple points of failure then in this kind of after treatment system just to use your generator outside of, an emergency standby event. If you ever wanted to maybe monetize or get a payback on your generator, like you have to have this very complex diesel after treatment to do so, where with natural gas or propane, especially the ones that Generac sells, we use different technology that doesn't require all of that after treatment. And we'll kind of talk about a little more of those benefits, I think, in the next two slides here. So looking at one of our 500 kW gas units versus the traditional EPA diesel emission tiers, right? So Tier 4 final is like the cleanest diesels available. With our 500 kW natural gas unit, you can see the red dot in the lower left. The actual catalyst out emissions are 94% less than what the Tier 4 final limits are for NOx on a diesel engine. And because it's natural gas, you don't have any particulate matter emissions. There's no need for a diesel particulate filter or anything. That just natural gas is just a cleaner burning fuel. So you don't see the black smoke out of it. You don't get that kind of soot or the worries of needing to have the after treatment on it, because it has a passive after treatment, just like is used kind of in your car in the automotive industry. We have a 3-way catalyst that sits in our exhaust stream, and it's able to reduce NOx, CO, and hydrocarbons all within one unit, and it's passive. So that means that you don't have to introduce any additional medium. So no diesel emission fluid, no routine maintenance, none of that extra headaches that are associated with it. It's just a cleaner solution already out of the bat than you would get from a diesel engine. So kind of again, touching base on the industrial natural gas offerings we have. So you can see the nodes on the right. We do offer natural gas or propane, so like a dual fuel solution or just a propane solution up to 150 kilowatts. So that would cover quite a lot of applications. And then, as Doug mentioned before, if you want to parallel multiple units together, we can hit, larger nodes just by using more smaller units. Again, one of the benefits of our natural gas, besides the super low emissions with that I just talked about, is the ability to start up, take load, and be online very quickly, right? So all of our products meet what's referred to as NFPA 110 Type 10, which essentially means from the time you hit the button or the automatic transfer switch switches over and says we need the generator to run, you'll be fully back, lights on and everything in less than 10 seconds, right? So it's a very short time that you'd even see any sort of outage. And if that's an issue, we can, put batteries with it so that, essentially you would see no blip in anything. And so kind of a hybrid offering like that, where, the batteries would cover the gap for the 10 seconds and then the generator would take over. These generators can take 100% load step. So, that's again, some of the nomenclature that people stick to with diesels is you can throw a bunch of load at them and you can't do that with gas. Well, you can do that with our gas engines. They can take 100% load step just like a diesel. But then on the flip side, we're also able to operate the machines at very light loads. So if you had a certain period of time where maybe you needed to run the generator at 25%, it's okay. There's you don't have to worry about wet stacking or other things that you might have to with a diesel. And then from the factory, we offer for emergency standby, we offer South Coast certification. So it meets all of the most stringent emissions requirements. And we also have non-emergency certification. So you can use it whenever you want to use it, right? It doesn't have to just be a utility outage. So this just kind of shows, again, nailing home the point of, we test every unit to be able to prove that it can do that 100% load step and load shed. And so this is just an example of our 625 kW natural gas genset. And you can see kind of the response that you get when you apply these really large load steps and kind of how long it takes to fully get back to recovered, right? So worst case scenario, you can see 0 to 100%. It has a pretty significant voltage and frequency dip, but then it's fully recovered and back stable in less than 7 seconds. So again, very robust machines and very, we'll say, diesel-like transient performance that you normally don't see out of a gaseous fueled engine. So now we'll just talk about a little bit of what we're seeing in the microgrid space and then kind of how we're participating. So the first example here is a project in Hawaii that actually is using a microgrid to power a homeless community, right? So it's providing like essentially tiny homes for up to 600 families that can kind of utilize these facilities. There's hot water that's provided by the solar thermal system. There's solar panels with battery storage. And then we have a 150 kilowatt propane generator there as kind of support to the renewables. And then this one actually has the utility grid as backup to the backup. So belt and suspenders to make sure, again, that these communities aren't impacted in any way for any power outages. But again, the renewables are all kind of the priority, and then the generator's there to provide resilience, right? So in case of storms or something happens to the solar, the generator's there to be able to support the load. We also have had a lot of traction with kind of grid edge microgrids, right? So supporting remote customers in high fire risk areas that, you know, the utility would have to pay a lot of money to upgrade the lines going to them. And so with these, we've actually partnered with like a containerized microgrid solution. So it's very minimal impact on, you know, the actual footprint, but then they have very high renewable penetration. So in both of these cases, over 90% of the energy provided throughout the year is going to be from the solar or the storage. And then it's got a propane generator as kind of a support for the storage, you know, in probably winter or at nighttime where maybe the solar didn't generate enough electricity to be stored by the storage. So you know, we're seeing that as kind of a really big trend on, you know, kind of these smaller systems that are able to have really high renewable penetration. So again, you have kind of your resilience and your sustainability goals can both kind of get checked off with one system.
And the other benefit to these kind of containerized or modular solutions is they're all pre-engineered and they're very easy to install. They can be installed on site within a day. And a lot of microgrids require very bespoke or customized engineering. Again, the benefit of these systems being kind of modular or off the shelf, you have the power requirements or the power output for these types of systems. You look at kind of what your power needs are, and then you can just kind of match the two up based on what your needs or requirements are for your facility, and really, you know, drop this on site and hook it up to your building or whatever you're hooking it up to, and you know it's able to generate and provide power, to Tony's point, for the entire year at a very, very high renewable component.
And then I think this is the last example we wanted to talk through, but this is an example kind of supporting the EV charging push, right? And it's kind of the same scenario here. This is actually an off-grid microgrid downtown of a city at a car dealership that is using the microgrid to power EV chargers within, you know, for the dealership, right? So it's a pretty unique setup, but it allows the dealership to then utilize the microgrid and charge the vehicles anytime, not having to worry about, you know, peak demand charges or rates or anything like that from the utility, where, you know, these systems again use the solar inside of these cabinets. There's the charger and batteries, and then you can kind of see in the top picture in the back corner we have again our 35 kW propane generator providing support to the renewables and kind of resilience to the system.
And this is an example, obviously, you know, in I'd say a small to medium-sized city, we're also seeing a lot of interest in this type of solution as electric vehicles become more and more common. We're seeing a lot of vineyards who have kind of wine tasting rooms or operations on site where people are coming out, you know, and visiting the vineyard from more metropolitan areas. They're increasingly interested in these types of solutions in order to allow, you know, EV charging at an affordable or an effective rate for the customers that are coming to their businesses. So that's kind of all we had, you know, prepared for kind of initial remarks. I know we have about 5-7 minutes here with the remainder of our time. Is there any questions that we can address or answer for the group?
Jan, you are muted.
Oh, sorry.
There you go.
I just unmuted. Sorry about that. Thank you very much to both Doug and Tony. Found that information very interesting, all the different options and possibilities. So I'm looking here. I don't see any questions. If anybody has any questions, we can take them just directly from the chat box. If not, what I've been doing is putting different resource links on the event web pages that we have. So I would definitely like to include your information there, and if there's anything else that you think we should include as far as helpful information, we'd be happy to let me know, and I'd be happy to include that. But you know, a lot of our growers are really, really small farms. So do you see very much where the residence is on site with the farm? Do you see, would those have to be separate units, or would it all be one system, most likely, for those kinds of situations?
Most likely you'd probably have a backup generator on the residence, and then a different generator, like say, you know, I'm working on a project now that has like a greenhouse in one area, and then they have a dairy barn in another area. And we were looking at kind of a parallel system to connect the greenhouse and the dairy barn, but using two different size generators for the two. But the residence would probably be separate than that, just from a feasibility of running wires to connect everything and all that.
Oh, okay. Okay. Great.
I did see a question in the chat. Are there any restrictions on the exhaust from these units? When you say restrictions,
Regulation.
We offer federal certification from the EPA for emergency on gas or diesel, and then non-emergency for our natural gas or propane products. So from a federal level, they're certified. Excuse me. Each individual air district within the state of California has their own limits and requirements. So I can say we're capable of meeting all of them. It just depends if it's our standard catalyst or if it maybe needs an oversized catalyst. But essentially the answer is no, there's no restrictions. We just have to make sure we scope the product correctly for the specific air board that it's going to. Hopefully that answers your question.
Jan, I can
Great,
share.
thank you.
I can share the information on continuing education while we wait for a few more questions to come in if you'd like.
Thank you. That'd be helpful. Thanks.
Okay.
Let's do that.
I'm going to share my screens real quick and go over this, but please, if you have more questions, place them in the chat. So for the San Diego Region Irrigated Lands Group, you don't have to do anything as long as you were logged in for the duration of the event. I'll take a generated list of attendees, get that over to Jan, and she will submit the credit on your behalf. For Certified Crop Advisor, that QR code is up. So just open your phone, take a photo with the app. If you don't have the app or you don't know what I'm talking about, but you still want your Certified Crop Advisor credit, you can send an email to A&R program support at ucanr.edu with your name and your login information, and I'll get you signed up. So I can leave this up. If there are more questions coming in, I'll type my email in the chat one more time. But that is it. As a reminder, it's the same link tomorrow for tomorrow's event.
Thank you, Kelly. Well, it looks like we can probably wrap up a few minutes early today. I want to thank everybody for joining us. And yes, please join us tomorrow. We'll be talking about water quality and nitrogen management in different cropping systems. And you're welcome to, again, check out the event website we'll keep adding resources as we go on throughout the week. And if you have any questions, feel free to contact either me or A&R program support. All right. Thanks again for joining us. Have a good rest of your day.